HPLC stands for High Performance Liquid Chromatography. It is a device used for separating mixtures, either to analyze the mixture or to separate a required product in a reaction mixture. It can also be used to detect concentrations. The principle on which HPLC works is the presence of two phases, a mobile phase, which is a solvent that carries the sample, and a stationary phase, which is a powdered silica packed into a column. The mobile phase is contained in bottles. The stationary phase is packed onto a column, like this. It contains silica to which a hydrocarbon chain is attached. This makes the phase nonpolar. Columns change depend on the hydrocarbon chain added, for example C18 or C8. HPLC contains a pump which pushes the liquid phase at high pressure. This may reach 1500 kilopascals. It also has a degasser which eliminates air bubbles to maintain uniform pressure. Before the sample is injected, it must be filtered using this filter to get rid of solids and insoluble particles. The solvent is also filtered. The sample is then injected no more than 100 microliters, as any excess goes to waste. We also have HPLC devices which have autosamplers. This runs the sample in order without any human interference. The solvent and sample are pumped onto the column. They then emerge from the column and pass into the detector. The UV light is absorbed by the individual components. The time taken for each component to come off the column is the retention time. This identifies each component. A chromatograph is generated, with each component having a unique peak. This is the UV-Vis setup. On the right is a spectrometer, and on the left, the computer which we use to analyze the data. First two cuvettes are filled with deionized water to be used as a reference. Only two sides of the cuvette can be touched, as the other two sides must remain clear for the light to pass through. Most cuvettes have a dimpled side to hold. Cuvettes are placed inside the spectrometer and the lid is closed. To run the reference, click AutoZero in the UV-Vis program and click OK. To run sample, take a small amount using a spatula and place in a beaker and dissolve in deionized water. Transfer sample into cuvette using a pipette, leaving 1 centimeter from the top. Put cuvette in the spectrometer and click Start on Program. Data is then acquired. It must be made sure that the concentration is not too strong so that the peak goes above the graph, or too weak so there is no peak. The example shown here is about perfect. Labels can then be added, such as height of the peak and what the compound is. Data can also be obtained without a computer, as the data appears on the screen on the top of the spectrometer. This is known as single beam acquisition. Before carrying out the titration, we need to add a few drops of indicator. It is important not to add more than 2 to 3 drops of indicator if you don't need it. A rough titration or overshoot titration can now be carried out to roughly gauge how much of the other solution is needed to neutralize the first solution in the conical flask. This is done by adding the solution from the burette until we see a permanent color change. The amount of solution added can be calculated by subtracting the final reading of the burette from the initial reading. Here we have added just over 16 ml altogether. Therefore, we can reasonably expect our accurate titration to require in the region of 15 ml of solution. For the first titration, we quickly add 14 ml of solution. We can then adjust the tap on the burette to add the remaining solution very slowly in a dropwise fashion. This is continued with regular swirling until the color has been permanently discharged. The amount of acid added can be accurately determined by performing a simple subtraction. The experiment is repeated until concordant results are obtained.